Hello guys, welcome back. Today we are going to understand today Leetcode question. Okay, so let's go and understand this question. Okay, so we have today medium based question, right? So this is 54, a spiral matrix based on 2D array, right? You can say. So we have given a matrix that is m cross n, and we have to return all the elements of the matrix in spiral order. Okay, so if you understand the spiral, right, spiral binding you have seen, right? So it is look like this one. Okay, like this. Okay, so this is a spiral band, a spiral order, you can say. So as you can see in the example, right, we have given this one. So it is how it is making actually, right? So it is starting from here, right? It is going down and then it is coming back like this, right? So it is not crossing because this is just an you can say a matrix, right? So it is starting from here, it is going down, then it will go like this, and then it will make like this, right? So this become a spiral, right? So to understand this, what you have to understand, you have to see visual, right? So for this example we have given this visual, right? But sometimes we have in the interview room you will not get this visual, right? So to understand that, what we will do, we have the input, right? So based on the input you can draw it, right? So we have given like 1 2 3, we have given 4 5 6 7 given in the input matrix, and we have to return in this fashion, right? So this is called you can say spiral binding, spiral order, right, of the matrix. Similarly, as you can see the example 2, we are getting the same like this, right? We are going to start from here, right, and we will come back like this as you're making the spiral thing, right? And with the output that direction will contain, that will be your output, right? So matrix is length and it's equal to n and should be greater than equal to 0 and less than like this. Okay, so this is the you can say problem statement we have given, right? So based on the problem statement, right, the question is the statement is asking, it asks us to return all the elements of the matrix in a spiral order, right? Which means we will start from the top left corner and move towards right. Okay, so when we are starting from right the top, right, we are, let's suppose we are moving to the left, right, here, and after that going to the left corner here, right? What we have to do, we have to on the top corner we have to just come down, move down, right? Move towards, after moving towards this direction, right, we have to come down and then left, and then we'll go to like up, and then we'll do this further this, you can say, like this is the way we will move, right? So as you visual you understand. So what we can achieve moving in this direction, like, so where there will be a different direction by moving row and column, right? That we have the indices, right? Column, row and column indices we have given. Especially let's suppose we have given a row and column. Just for example I am saying, let's suppose we have row and column we have given. Okay, so where the row is row index and column is the column index, just for example. Okay, because we are taking matrix. So if matrix have m cross n, so if this is the m is the row and this is the column, just for example. Okay, so if row indicates row indices and column indicates column indices, right? Now we will move right. To move right, let's suppose I'm saying move right, just for example, means we are going to start from here and will come in this direction, right? In this direction, as we are going like this, right? We are going to this direction. Okay, means move right. To move right, what we have to do, we have to say row will remain same. This is the row, same row, because in the same row we are moving, right? But column we have to say, right, column plus 1, correct? This will become row and column. So this is the thing we will do for moving right side, right, in moving right direction. Okay, so if we'll say move what, downward. Let's suppose we are going to say move downward. To move downward, what we have to do, like for I'm calling about this one, this direction, right? So if we are going to down, right, what we have to do, so column will remain same, right? Because this is the same column. Let's suppose this is a C1, C2, C3, C4, and this is R1, row, R2, R3. Okay, so when we are moving, we are going downward, moving downward. So C4, only C4 will remain same, right? Means C will remain same. Okay, then row will increase, correct? So this time we'll say row plus 1. right? So this will become when we are going downward, right? Similarly, when we are going to move, let's suppose we are going to move left, right? Let's suppose for the left means we are going to this direction, right? Like this, okay, this direction. So when we are going to this direction, move left, what we have to do, right? So column will remain same, row will remain same because on the R3, right? So this is R3, R will remain same. Only what we have to do, column we have -1, and this we can say column, okay, column -1. So this will become 4. We are moving to left side, this direction, from right to we are going to left direction, okay, like this. Now if we'll talk about move upward, okay, if anybody going to upward, at that time upwards, what we have to do, column will remain same, right? For this one, for this direction, okay, column will remain same, C1, but row will decremented from R3 to R2 we will go, right? So at that time we will say row -1. This is row -1. So this is the 4 direction we have to focus on, right? So now you understand how we will achieve moving in different directions, right? So these 4 directions we have to take care of while implementing this example, right? So when shall we change our direction, right? We need to turn when we either reach the matrix boundaries, right? So or we can say we'll reach the cell in the array that we have visited before. Got it? I'm trying to say when shall we change our direction. So when we need to turn when we either reach the matrix boundaries, right, or we reach the cell in the array that we have visited before. Got it? So matrix boundaries are fixed, okay, and provided already. That is already, right, we have. But how could we know if we have visited a particular cell or not? Got it? Means matrix boundaries we have fixed, that is already provided, right? But how we could know if we have visited a particular cell or not, right? So in fact we have different strategy, and they will be introduced in this approach, right, that we will see. We have multiple approach, we'll go through that. So before that, let's understand, like they are as let's suppose we'll take one approach, right? Just for example, let's suppose approach, we can move the boundaries toward the center of the matrix, okay? We will move towards the center of the matrix, and we have traversed a row or a column. Then we meet a boundary when known, right, it's time to change the direction or update the boundaries, okay? Or another approach, what we can do, while traversing a matrix, we can record each location that we have visited, right? Like as we used to do in the you can say graph, right? We will make a visited and we'll store there, right? So if we have already visited, no need to visit again, right? So then we can meet a matrix boundaries or previous visited cell, and we know it's time to change the direction, right? So there can be two approach. The first approach, we can move the boundaries toward the center of the matrix after we have traversed a row or column, okay? And then we will we meet a boundary and we know it's a time to change the direction, and similarly we'll update the direction. Another approach, what we can do, while traversing the matrix, we can reach location and we have visited, right? So then what we will do, when we meet a matrix boundary or previous visited cell, we know that it's time to change the direction. So these two approach we will follow, and we'll try to implement this one. So first of all, we will go to the we'll do the setup of the boundary, right? So first we'll go to with the setup boundaries. So our goal is to update boundaries. Let's suppose so before understanding anything, let's these are the companies that we have already asked this question. This question is very important. As you can see, this question has been asked in multiple interviews course, right? And from the last you can say last consecutive interview, Amazon has asked multiple times, right? Google, as you can see, the top company like Google, Microsoft, Apple, every top companies are asking this question. Okay, so let's understand the approach that we are going to follow. Let's suppose we have what we can say, we have a matrix. So, okay, let's suppose like this, just for example. Okay, so this is this is a boundary, let's suppose. Okay, so our goal is to update the boundary, right? So when we finish traversing a row or column, we want to set up a boundary on it, so that the next time we get there, we know we need to change the direction. Okay, so here is a demo for the first round of the updating the top, right, bottom and left boundaries. So let's understand. This is the, let's suppose, original boundary we have at the top corner, right? So we'll say this is your boundary. Let's suppose this is the boundary that we are talking about. Okay, okay, this is the boundary. Okay, next time what will happen when we move to this direction? Let's suppose, so I'll move to this direction initially, right? So we have started from here, right? And then we came to some point, right? So initially we were here, right? Now we are at here. Okay, so this point is no more now, right? We are at here, correct? So if we will traverse from here, right? So again we are traversing down, right? So we have reached here now, but we are not at here correctly. So like this we will traverse. So we are making our bend, we are crossing this one, so this become our boundaries, right? So we reached now, let's suppose here, right? After crossing this, let's suppose we are going to somewhere, and then we will reach to our center like this, right? Each time we will go and we will make this similarly we'll do, right, like this. Okay, so once we will reach the boundary, okay, when we will reach the boundary, so we will implement this implementation, right? What we have to do, we will initialize the, let's suppose if we are not going here, right, we will go to here. So this will become your complete boundaries, right? This is your boundary. Okay, so what we have to do, we'll take top, right, and you can say bottom and left boundaries. So you can say up, right, down and left, we can say, right? And then we will do this, we will follow these directions, we will update each time, and we initialize our output array, right? And that we will traverse the element in the spiral order, and each time what we will do, we'll add each element in the output array, right? And we will traverse from left to right. First we will left to right will traverse, then we will traverse up boundary to down boundary. Then what we will do, before we traverse from right to left, right to left, right, we need to make sure that we are not on the row that have already been traversed, right? If we are not right, we are not then we will we can traverse from right to left. And similarly, before we traverse from top to bottom, right, top to bottom, you can say this one, then at that time whatever we need to make sure that we are not on a column that have already been traversed, and before we traverse from the top to bottom, right? So what we will do, we will remember these move on the boundaries, like we will update each time left, right, up, down, these things we will update, and will return the output after updating each time, right? So what we will do, let's suppose we are going to implement this one, right? Just for example, let's suppose we are going to implement this one. So to implement this one, what we have to do, we will initialize this variable. Okay, so let's go to the browser and we'll do implementation. So let's understand here, let's continue here. So we have given this matrix, right? We have given this matrix. So what we will do, let me start from here. Okay, so first of all we'll take we have to do a spiral order, right? So we'll take array and we'll store there, right? So let's suppose we are going to use a linked list, right? So let's suppose list will take, and this list will become integers of array, right, like this, and this is nothing but our answer. Okay, answer of spiral orders, right, that will store, and this is nothing but our new array list, like this. Now what we will do, we have our row and column. So to find from the row and column, what we have to do, we'll take int, right? What is rows? This is our rows. We can rows get from matrix dot length, like this. Similarly, we'll get columns, right? To get the columns, what we have to do, cols equal to matrix dot matrix at length, we can take, right? Matrix at, let's suppose 0, the first row, right? And we'll find from the first row we can do length, right? So we will get from the first row, we'll get all the columns. After this, we will initialize some directions, right? Up direction, left direction, down direction, that we will do, right? Let's suppose 4 directions, 4 direction, 4 move, okay, like this. What we have to do, 4 directions we will take, and 4 directions variable will take 4 directions, 4 move. What, how we'll do, we'll take let's suppose we'll take int, and this is nothing but our we first initially we'll go to up. Let's suppose up will start from 0, okay, then we can take what, left, then we are going to left equal to 0, sorry, like this, and then we can take what, right, I'll take right, this will also start from 0, and up, left, right. So right will not start from 0 actually, right, we will start from the column -1, last column, right? So we have already columns, right? From the columns we can take -1, and we'll start from the last column, okay, right? Then from while we're doing down, we will start from what, let's suppose we have down. So down we will start from what, last row, last rows -1. We have to understand this. See, what I'm trying to say here is, let's suppose we have given I'm going to here. So this is the we are going from what, this direction, correct, and we reach here. So from when we are going to right, we are at right. So from the right, this is the last column, this is C1, C2, C3, okay. So total column is what, size is 3. So from the 3 -1 we will do, and this will become what, 2, because this index is 0, this index is 1, and this index is 2. So we'll start from here. That's why we are taking columns -1 for the right, okay. So rights will become always what, we have all columns we have, let's say calls -1, that's so that we will be at here, okay, at this location, okay. For down, because we are at this rows, so this is R1, R2, and R3, okay. So when we are doing R1, R2, R3, just for example, when we are doing for R1, R2, R3, what we will get, we'll get at this position. Let's say just for example, for the down, right, we are at this location, right? The rows, this is our R3. So total rows we have, so from the rows -1 we will do, and that will be our down, right? This is your down, and this is your right, and this you can say up is at 0, this is your up, right? And what is left, yeah, this is left, okay. We can take left, you can take any position for the left, okay. I think you got it. Let's come back to our implementation, okay. So these 4 direction we will take. Now what we have to do, we'll move to the all the row and columns. Let's suppose, because we are reducing the we are traversing, right? Let's suppose we have our answer we will update each time. How we will do that we will see later. Let's suppose our size is always less than rows dot, not dot, it's a column, you can say calls, row into calls, right? We have row into call, and if answer is less than row and calls, means we are not traversing all this, right? So the size should always less than row and column, because answer should be equal to the matrix maximum, max, not it's greater than. So we'll take this condition, means all the elements that have in the answer should be always less than this matrix number, because we are doing a spiral, right, at that time. Now what we have to do, we will traverse from left to right. Just for example, we'll start from left, where is this? Yeah, this direction will start from here, will start from this left and will go to the right direction, this one. To do this, what we will take actually, we'll start from column what, 0, means this is our left and right, we will start from here only. Okay, left and right will start from here only. Okay, so we'll start our left from here and we'll go to till there, right? So each time what we'll have to do, column will increase, c1 c2 c3 column will increase, right? And we are starting our left from here only, means we are starting from 0. That we will do. It means what we have to do, let's suppose we have here a for loop. Okay, so the for loop, what we will do, will take int, this is our calls, right? So column we will start from where, we'll start from left, right? And each time our column will increases, right? So to do that, what we have to do, less than equal to, we'll say less than equal to right. Okay, and call plus plus. So we have our call right is what, right is our column minus all calls minus 1, right? Right is all calls minus 1 and left is what, 0. So we will go to 0 to the call minus 1. So this will be our first move, right? So this move is nothing but our let me write here somewhere. Yeah, we can write here. So this is our move from, we can say left to right, left to right we are doing, correct? Now coming back to here, we have the our answer, right? So on the answer, this time when we are doing the move, we have to add, correct? So that we will return. So if I'll do dot, right, and we'll add the elements, to add the element from the matrix, right? So we have already what, sorry, not answer, this matrix, right? We have already this matrix, right, that we will do. So after matrix, we have to take two things. First, we'll start from up, because we have up, and then we'll add all the columns from the up, right? Sorry. Okay, sorry. Okay, like this. Now we have already added one. So for the first row from left to right, we will get it and then we will return it. So finally, let's suppose I'm going to return this number. So for the first move, we will return like this. Now for the second move, what is the second move? Now we will say, let me go here. Now we have come to here, right? So we reach to from here to here, right? From here to here we reach. Now we have to take this point to, we will reach to this point. Okay, you can say this is our downward, right? So this downward direction we have to move. So for the downward direction, right, this is our row, right? But this is our up. Okay, but this is our up. So row will start from where? From up plus 1. Up plus 1 will move like this, right? So what will happen? Our row will start from here, right? Our row will start from here, but it will increase plus by the plus 1 will come to here, right? So to do that, what we will do? So let's suppose the same thing I will keep here. Only what changes I will do? See, you have to focus only on the changes, right? So now our this is not row, right? This is not column actually. This is our row, but our row will start from where? Initially up we have. So from up plus 1 will do and will move, right? Now this is not our column, this is our row. So row should come to what? Which position? It should come to down. From up to down, right? Will come, and then this is our row and we are move downwards. This is our move downwards. Like this will go. But here things will change, right? We are traversing downwards, right? So this is our row, correct? And this is our right, because we are at right. Where are moving? this is the point we are talking. So we are at right, this direction, right? This is our right. Okay, you got it. Now next we will move. For the next move, what we have to do, we have reached let's suppose, where are we? Here. So here we have reached at here, right? This position. Okay, so once you have reached at this position, we have to reach where? This position, correct? So this direction should go like this, correct? So to do that, right, means make sure like we are now at different row. We are not at here, we are reached at this row, just for example. Now up should not equal to down. We will make the condition first, right? Why? Because if up and down are equal, means we are not at the right direction, right? First we will make sure that this check should be there. Up and down should not be equal. Now what we will do, then we will traverse from where? Right to left, this direction. Okay, so this time what we are going, we are at column as where? This one, column at this one, correct? So we'll start from right. So we'll do at right minus 1, we'll start, and we'll go to our column, will go to here till left. This is just nothing but what? Left. This is your right, and this is your left, right? So from right to left we'll go. Okay, let's come to, okay, now we'll make for loop, and then we'll say before the for loop, what we should do, actually I forget to write, we have to make a condition. If the check should be always be there. What check should be there? It should not equal to down, like this. It should not equal to down. If this is the case, right, why we are doing actually, so this condition why we are doing actually, so we should always be at different row. We should always be at you can say different row, so that we will traverse from right to left. So to now you can move from what? Right to left, correct? How we'll do that? To do that, what we have to do, we'll make a for loop, right? So for loop will start from where? We'll start int column should start from where? Column should always start from right minus 1, the last column, and then column should always greater than equal to up, means maximum up we have to go, right? And column should always greater than equal to left side, right? Left. And right from right minus 1, then we have to go to left and say column we have to decrease minus because we are coming from right, and we'll reach to left, correct? So coming back to here. Okay, so what we have to do, we'll add this answer. Just we will update Leetcode. So matrix will remain same. Now this is nothing but our what? Down. At down, I think I have inserted something. Yeah, at down, what I will write? I will write what? First we'll take down, and then we'll take column. From down to all the column will go, means from down we'll go to all its column, right? 3, 2, C3, C2, C1, like this will go. You got it. Now what we have to do, if let's suppose one more check we should be here. Okay, now we have to take a condition. We have to say that we should not be always on same column, right? And to do that, like this we have to make for another check. How we'll do that? You say if left is not equal to right. Just for example, left is not equal to right. What I'm trying to do here is I'm trying to say we should always be on different position. We should always on different columns like this, you can say. To do that, now we can move upward, right? Now we will move upwards like this. Okay, to move upward, what we have to do, we'll make a for loop. Okay, and we'll say int what, row equal to what, down minus 1, and then row we'll start from row down minus 1. From down, the last row, down minus 1 is nothing but our last row, right? And then row should be greater than up, and then row should be minus minus. Correct? Why I'm taking the space, it's not required. Okay, now what we will do, we will add on the answer. Similarly, just we have to update Leetcode. What, this time this is our row, because we are decreasing our row. Now at the column, this is nothing but our left, at the left corner we are doing, right? Now everything is done, we are returning our result. But what we are not doing, we are not updating our left as a, you can say plus plus, left plus plus. What we are not doing, another thing, we are not saying right minus minus. So how we'll update each time, right, minus minus, and then up plus plus, and then down plus plus. Okay, so if you, why I'm doing this one, if I will remove from here to here, now you will clearly understand, right? From here to here I will remove, then you will understand. But here we are using left and right, so that's why at that time we will write here, because left we have to increase, right we have to decrease, up we have to increase, and down we have to increase. Sorry, down we have to do minus minus. Down we have to do minus minus, right? Up will increase and left will increase, and right will decrease and down will decrease. Okay, let me check actually. Okay, it's working. Let me submit. It's working for me. Okay, now we'll understand complexity thing. Okay, so if we'll talk about the complexity, let me first recap, then we will go to here. So first of all, what I have did here, we have taken row and column, then we have started up is 0, left is 0, and right will start from the last column, and down will start from the last row. Okay, first we'll move the left to right move, and we'll start from left. Column will start from left and will go to the right, and we'll add all the answer. Similarly for the downward, up we will start from up plus 1 and we'll go to the down and we'll add all. Similarly we'll for the right to left, we will go to right minus 1 and we'll update our left will increase, right? So down and then call, right? So each time we are doing down minus minus, right? And then we will column will get decreases each time, as you can see. From the last column will start and then we'll go to the first column, right? Similarly for the up direction, row will get updated, row will decreases actually from the last row to up direction will go, and will update all the things, and finally we'll remove we will return, sorry, right? So as you can see here, if matrix have a column into row, right? So if I'll represent column as a, you can say number of rows we have m, just for example, and column we have just for example n, right? if we have m and n, so as you can see, we are traversing all the row and to column, right? Row and column we are moving. So total time complexity you can see, that is we can write here. So similarly, this is the matrix, so you can say that O m into n time complexity. And for a space complexity, right, we are not taking any extra spaces, so that will 1 of 1. So let me write here. Okay, thank you guys, thank you for watching this video. If you like this video, please hit subscribe this channel so that you will get more videos like this. Thank you.